Hi students, welcome to live section of Kerala NEET Academy. Myself Rajiv sir. Today I am going to discuss some questions from chemistry topic. The topics are hydrocarbon from 11th standard, electrochemistry 12th standard and chemical kinetics also from 12th. We already sent the live topic for these chapters. I think you all run through the topic. You are getting the idea regarding the topic also. Now we can move through some questions based on this topic. Okay, we can start now. The first question. The question is, which is most stable? The stability of molecule. The option given are, first one is cyclopropane, cyclobutane, cyclopentane and cyclohexane. See, all are cyclic compound. You know, in the case of cyclic compound, as the number of carbon atom increases there in hydrocarbon, the stability of the molecule also increases up to cyclohexane. So why cyclohexane is more stable? Because the 6 carbon atom are in cyclic ring, so it is not in a plane. Okay, so the stability increases as the number of carbon atom increases in cyclic compound. So which is the correct option here? Cyclohexane is the correct option. Are you getting the idea now? In the case of cyclic hydrocarbon, number of carbon atom increases, stability increases up to 6 carbon atom. Cyclohexane, it is not a planar molecule. Okay, so ring is not planar, so the stability increases up to cyclohexane. Okay, now we can move to the next question. The question is like this: a compound react with soda lime. In organic chemistry, we are using soda lime for decarboxylation. What is the meaning? Removal of carbon dioxide. Carbon dioxide can be removed only from carboxylic acid. Only carboxylic acid contain 1 carbon and 2 oxygen atom. So from carboxylic acid, all carboxylic acid, it contains COO group and the Na, sodium salt. When you are using soda lime is NaOH and CaO. Mixture of NaOH and CaO is soda lime. When it is added, this sodium hydroxide and this CONa is removed as Na2CO3, sodium carbonate, and the hydrogen, remaining one hydrogen will be there, that will be added to the remaining alkyl group. So you are getting a hydrocarbon. So the hydrocarbon, it is given CH3, CH3. This CH3 is connected to the second carbon, then only the valence will be correct. Okay, the molecule is total how many carbon atom there? 5 carbon atom. Second carbon atom CH3 group. Second carbon atom CH3 group means we can use the root name iso. So the molecule is isopentane. So when CONa is removed from the given options, which case you are getting isopentane? See the second molecule, just to see second molecule. When you are removing this CONa, you will be getting isopentane. And the third molecule also, when you are removing this CONa, the same molecule, CH3, in this case, the right side in the CH3 is in the second carbon atom. So both 2, 1, 3. On decarboxylation, you are getting the given molecule isopentane or 2-methylbutane. Clear now? The process is decarboxylation, removal of carbon dioxide. If it is a simple molecule, acetic acid, when you are conducting decarboxylation, you are getting the molecule methane, CO2 removed, remaining only CH4. You take like that, more example we can think about any carboxylic acid. You take benzoic acid. What is the formula? C6H5COH. Sodium salt, CH5CONa. You are removing carbon dioxide, remaining benzene. You are familiar, salicylic acid, OH and COH. We are removing carbon dioxide, remaining phenol. Like that, you can practice more questions related to this question. Any carboxylic acid you consider, on decarboxylation, carbon dioxide is removed, remaining hydrocarbon you are getting. Is it clear? Shall we move to the next question? which is not prepared by Wurtz reaction. It is an important name reaction there in chemistry, Wurtz reaction. For what purpose we are using Wurtz reaction? For getting higher alkane from lower haloalkane. Most commonly we are getting even number of higher alkane from lower alkane. For example, CH3Cl, when you are conducting Wurtz reaction, what is the product you are getting? The product is ethane. Even number of higher alkane you are getting, CH3Cl. On Wurtz reaction, ethane. CH3CH2Cl, on Wurtz reaction you are getting higher alkane. Even number of higher alkane mainly we are getting. Odd number also we can prepare. Mixture of haloalkane when you are using odd also you are getting. But practically it is not applicable, because in that case sequence of alkane hydrocarbon you are getting continuous 3 member, 4 member, 5 member. So difficult to separate them. That is why practically we are not using. But anyway, Wurtz reaction you are getting higher alkene. So which one you cannot prepare? Because methane is the lowest hydrocarbon, only one carbon atom. We cannot get it by Wurtz reaction. So third option is the correct option, methane. Wurtz reaction we cannot prepare methane. Okay, shall we go to the next question? There also one alkyl benzene is given. Which alkyl group is there? Ethyl group. Ethyl group is connected to benzene, can be prepared by aromatic ring. We are connecting on alkyl group. So there is a combination of haloalkane and haloarene. Then only we will be getting alkyl benzene. Which is that reaction? If haloalkane alone we are conducting, and the reaction we are calling Wurtz reaction. If haloarene alone you are taking, and the reaction we are calling phytic reaction. Here the product is the combination of haloalkane and haloarene. So the reaction is called Wurtz phytic reaction. So which is the correct option? Third option will be the correct option. Wurtz phytic reaction. It is the reaction between haloalkane and haloarene. Is it clear? Okay. Shall we move to the next question? Question number 5. In the following compounds, the decreasing order of boiling point. You know, in the case of organic compound, boiling point is the common concept for all organic compound. The general property regarding, or general things regarding boiling point is, as the branching increases in any organic compound, branching increases, so the surface area will decrease. Surface area decreases means its rate of vaporization will increase. That means branching increases, boiling point decreases. Branching increases, boiling point decreases. Here they are given the option. First one is a straight chain molecule, so that has a maximum boiling point. Second one branch, third one 2 branch. As the branching increases, boiling point decreases. So which is the correct option? First option will be the correct option. Okay. Not only in the case of hydrocarbon, all organic molecule, as the branching increases, boiling point decreases. Okay, are you getting the idea now? Now we can move to the next question. So you are getting on hydrocarbon. Next question. That on chlorination in the presence of sunlight. In the case of all alkane, when it is treating with chlorine in the presence of sunlight, the reaction is an example of which type of reaction? Free radical mechanism. One of the CH bond will break it, and we are getting a free radical, and the free radical hydrogen is replaced with chlorine free radical. So the product is one chloroalkane. So in this molecule, what is the molecule? CH3, CH3, CH2, CH3. Here, how many replaceable hydrogen? When you are replacing one hydrogen, we can replace a hydrogen from this CH3, or you can replace from this CH3. Both the case you are getting same product. Chlorine, when you are substituting either one CH3, the IUPAC name will be same. Then next one, here hydrogen atom you can replace with chlorine. Here hydrogen atom you can replace with chlorine. Here hydrogen atom you can replace with chlorine. So there is a chance for how many different monochloro derivative? 4 monochloro derivative. Okay. Here they are asking which one will be the major product of this reaction. Okay. Major product means which hydrogen will be readily replaced and you are getting a stable free radical. Among the free radical, say, first hydrogens from the CH3 I am replacing, these two CH3 I am replacing hydrogen, you are getting a primary free radical. In the two cases, primary free radical. Then in this case, when you are replacing hydrogen, what type of free radical you are getting? Tertiary free radical. Here it is a tertiary free radical. Here which free radical? Secondary free radical. Here primary free radical. Among the 3 free radical, which is most stable? Tertiary, then secondary and then primary, due to plus A effect of alkyl group. So which one is the most stable halo compound you are getting? Based on the stability of free radical. Which free radical is the most stable? Tertiary free radical. So the second option will be the correct option. Are you getting the idea now? Here the mechanism is what type of mechanism? Free radical mechanism. One of the CH bond will be breaking and you will be getting free radical. Among these replacement of hydrogen, which free radical will be most stable? That will be the most stable product. Is it clear? Okay. Shall we move to the next question? Question number 7. It is based on one aryl magnesium halide is given as the reagent. There we are adding D2O. What is D2O? Heavy water. One Grignard reagent, alkyl magnesium halide or aryl magnesium halide. It is called Grignard reagent. Okay. When R or AR Mg X or MgBr. This is the general format of Grignard reagent, organic compound, covalent bond. When it break, how it is breaking? Metal, non-metal part, this part will be breaking. And the metal is getting positive charge and the other part is getting negative charge because metals are electropositive character. This way only it will break. Then what we added here? Heavy water, D2O. It contains D plus ion and OD minus ion. Water contains H plus and OH minus. D2O contains D plus and OD minus. So what is the addition? So in this molecule when you are adding, D will be connected, D plus will be connected to aromatic ring and OD will be connected to magnesium. So in the aromatic ring, what will be connected? That ring D will be connected. Deuterione will be connected to aromatic ring. So the product is deuterione benzene. So second option will be the correct option. All Grignard reagent, this is the way it will be breaking. RMgX general format. RMg will break. R will get a positive negative charge, Mg will get a positive charge because metals are electropositive in nature. Okay, are you getting the idea now? Are you following? Okay. Shall we move to the next question? 8th question. In which alkaline isomerization will not occur? Isomer. Okay. In an important topic there in chemistry, isomerism. Variety of isomerism we are studying there in structural isomerism and stereoisomerism. Structural different category we learned. Okay. Chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism. These are the main structural isomerism. Okay. See, for writing the isomer, minimum how many carbon atom is needed? Minimum 4 carbon atom is needed. Then only we can represent a branch. 3 carbon we cannot represent a branch. 4 carbon atom, 3 we can include straight chain, and 1 carbon you can take it as a branch. So minimum 4 carbon atom is required for writing isomer. So here which one not possible? The first molecule C2H6, CH3, CH3. Any direction when you can write it, only CH3, CH3. No isomer. So first option will be the correct option. Okay, so from this question you must understand, for writing isomer minimum how many carbon atom is needed? 4 carbon atom, starting from butane. Okay, are you getting the idea? Shall we move to the next question? Question number 9. Are you following? Yes. If you are having any doubt, you can ask. Okay, then I am moving to the next question, 9th one. There, the molecule given, just to see the molecule. First one is a benzene ring C6H5. There we connected to an alkyl group. Any alkyl group we can connect it. Methyl, ethyl, propyl, isopropyl, butyl, isopentyl. Any one we can connect there in benzene ring. Just to see benzene ring. I am generally writing any alkyl group. Here which alkyl group they given? Propyl group. Ethyl, propyl, anyone. When we are conducting oxidation with KMnO4, alkaline KMnO4 or acidified KMnO4, it is a powerful oxidizing agent. When we are adding KMnO4 to any alkyl benzene, this alkyl group completely oxidized into which group? COH group. Remaining carbon all will be converted into carbon dioxide and water. Okay, toluene, ethyl benzene, propyl benzene, isopropyl benzene, butyl benzene, all you are getting the product is one benzoic acid. It is an important reaction. Okay, alkyl benzene on oxidation with a strong oxidizing agent, you are getting benzoic acid. If it is a mild oxidizing agent, you are getting benzaldehyde. Okay, are you getting the idea? So second option will be the correct option. Now we can move to the next question. What is the true statement about a conformer of ethane? Okay, ethane, hydrocarbon having one more type of isomerism, conformational isomerism. What is conformation? It is the change in configuration due to free rotation of carbon-carbon axis or carbon-carbon bond. Due to free rotation, we will be getting number of isomer. That is called conformation. From these number of isomer, we are considering two of them are extremes. They are named as eclipsed form and staggered form. The detailed that is given in the NCERT textbook. Go through the sentence one by one. Their energy difference, rotation, restriction, all are clearly explained in the textbook. So go through the content. Energy value 1 to 20 kilojoule, that energy restriction is there. Okay. So there, with respect to one carbon, another carbon atom we are rotating. So that carbon-carbon axis free are rotating. So each bond, the rotation is specific. So all the three bond continuous sequence they are rotating. So there is no change in bond length, no change in bond angle. But each and every moment that all the three simultaneously equal way they are rotating. That is conformation. So what is the correct option here? Both bond angle and bond length remains same. But number of conformations we are getting in each and every second. From that conformations, two of them are extreme, that labeled as eclipsed and staggered. Other conformations are called skew forms. Okay, so fourth option will be the correct option. Okay, are you getting the idea? Shall we move to the next question? Okay, next question is based on the topic chemical kinetics. Kinetics mainly we are studying rate of reaction, rate constant, order and molecularity, and the factors affecting rate. That is the content. Here, one reaction is given and the concentration of NO2 increases by 2 into 10 to the power minus 2 moles per liter in 5 seconds, the rate of the reaction. Based on their chemical equation, they mentioned the concentration of NO2. So with respect to NO2, we can write the rate expression. Rate is equal to change in concentration with respect to change in time. Rate we are always calculating for 1 mole. Here the equation NO2, 4 mole will be forming. So rate based on NO2, because NO2 concentration is mentioned there in the question. So what will be the rate expression? 1 by 4 per mole concentration of NO2 by change in time. That is equal to 1 by 4 into what is the concentration of NO2? 2 into 10 to the power minus 2 divided by time, 5. Okay. So you are getting 5 into 4, 20. Upper 20 ile 2, 2. 5 into 4, 20. 2, 2 cancelled. Upper 10. Upper 10 to the power minus 3 numerator. That only there. Upper 10 to the power minus 3 mole liter inverse second inverse. What will be the correct option? Third one will be the correct option. 1 into 10 to the power minus 3. Clear? Rate is equal to direct formula. Change in concentration by change in time. Rate we are always calculating per mole. So for 1 mole, 1 by 4. If you are calculating with the N2O5, then you have to write 1 by 2 concentration of N2O5 by change in time. O2, no need of fraction, 1 mole only. But delta of O2 by delta T. All are same. Because how much reactant is reacting, that way only product will be forming. Matter can either be created nor be destroyed. So we can calculate rate either with the reactant or with the product. Clear? Are you following now? Okay, then shall we move to the next question? Question number 12. The rate law expression is given based on a chemical reaction. Rate is equal to rate constant into concentration of NO2 minus into I minus into H plus the whole square. 3 concentrations are there. Now we are increasing the concentration into tripled. What will be the rate? Triple times we are increasing. Upper rate is equal to K into 3 into NO2 minus, then 3 into I minus and 3 into H plus the whole square. So the rate is increased by 3 square into 3 into 3. 3 square is 9, 9 into 3 27, 27 into 3 81. So the answer is 81. Fourth option will be the correct option. Clear now? Each concentration is tripled. So 3 times you have to increase. That time you are getting the rate. So the rate is increased by 81 times. Clear now? Shall we move to the next question? The rate constant of a reaction is given. Rate constant, liter, mole inverse, second inverse. Then order of the reaction is. How can we identify from the rate constant order? From the unit we can identify. What is the general unit or rate constant? The rate constant general unit is mole power 1 minus n, liter power n minus 1, second inverse. What is n? N is order of the reaction. If it is a zero order reaction, n is equal to 0. So what will be the unit? Mole, liter inverse, second inverse. If it is a first order reaction, what will be the unit? Second inverse. If it is a second order reaction, n is equal to 2, second order. What will be the answer? Mole inverse, liter, second inverse. The same unit will be there in the question, rate constant. So what is the order of the reaction? It is a second order reaction. Okay, next question. The rate constant of a zero order reaction rate constant is given. How long will it take for initial concentration changes from 0.1 to 0.075? How to calculate time interval for, the rate constant expression for a zero order reaction, K is equal to R0 minus R by T. Here you have to calculate a time interval. T is equal to R naught, initial concentration 0.10 minus 0.075 divided by K. What is the K value? 0.003. When you are taking the difference, 0.1 minus 0.075, 0.025 divided by 0.003. So the answer is 25 by 3. What is 25 by 3? Answer is 8.3. Direct formula we can apply. Rate constant expression for a zero order reaction, R naught minus R by T. All are given in the question. When you are substituting, you will be getting 8.3. Fourth option is the correct option, 25 by 3. Okay. Are you getting the idea now? Then next question. If the initial concentration of a zero order reaction is 5 into 10 to the power minus 2 and the rate constant is 0.0025, then T half-life for the reaction is zero order reaction half-life. What is the equation for half-life period of a zero order reaction? T half is equal to R naught by 2K. Half-life period is directly proportional to initial concentration of the reactant. R naught, what is the initial concentration? That is given 5 into 10 to the power minus 2 by 2 into 0.0025. 5 into 10 to the power minus 2 divided by 2 into 5 into 10 to the power minus 2 divided by, here 25 into 10 to the power minus 4. 25 into 2 means 50. 50 into 10 to the power minus 4. 5 by 50 means 1 by 10. But 10 to the power minus 3. So 10 to the power minus 2 into 10 to the power 3. So what will be the answer? 10 will be the answer. 25 into 2, 50. 25 means 25 into 10 to the power minus 4. 5 by 50, 1 by 10. So you are getting the answer 10 second. So first option will be the correct option. Are you getting the idea now? Are you following? T half of a zero order reaction, R0 by 2K. T half is directly proportional to initial concentration of the reactant. So direct formula R0 is given in the question, K also given in the question. So you can substitute, you will be getting 10 second. Okay, next one. A first order reaction has a rate constant. First order reaction rate constant is given. How long will it take for 6 gram reduced to 1.5 gram? Okay. 6 gram. Weight difference is given. You just go through that weight. 6 gram converted into 1.5 gram. Okay. Suppose if you are considering the half-life, in the first half-life 6 is converted into 3. Second half-life 3 is converted into 1.5. That means during this change there we are taking 2 half-life. What is half-life of a first order reaction? T half is equal to 0.693 by K. From that you are getting half-life period because K is given in the question, 0.693 by 0.0693. What is the T half? T half is equal to 10. Here for this change in concentration, how many T half is required? 2 T half. 1 T half is 10. So what will be the answer? 20 is the answer, 20 second. 2 half-life will be taking for this change. So the answer is 20 second. So third option will be the correct option. Any question when you are getting the weight change like this, that weight change you have to check it. It is the multiple of half-life. Then directly you can calculate. Okay. Are you getting the idea now? Okay. Now we can move to the next question. According to Arrhenius equation. Okay. What is Arrhenius equation? K is equal to A e power minus A by RT. Taking log on both sides, ln K is equal to ln A e power minus A by RT. That is ln K is equal to splitting log A into B, log A plus log B, ln e power minus A by RT. That is ln K is equal to ln A minus A by RT. What is ln E? ln E is equal to 1. So now we can correlate this equation. Ln K is equal to minus A by R is a constant into 1 by T plus ln A. Now this equation is similar to the equation y is equal to mx plus c. So y axis you have to take ln K and x axis you have to take 1 by T. What is the slope? Negative slope minus A by R. So from the given graph, which one is a negative slope? First one. So first option will be the correct option. ln K against 1 by T, negative slope. What is the slope of the line? Slope is equal to minus A by R. Clear now? We are correlating Arrhenius equation. That equation we are correlating with y is equal to mx plus c. Then you will be getting. Clear now? Are you getting the idea? Now we can move to the next question. The time taken by first order reaction with the rate constant K to change its concentration from 10 molar to 2.5 molar. 10 to 2.5. Again you have to check it. The change is in the multiple of half-life 10. First converted into half-life 5 molar. First half-life. Again next half-life 2.5 molar. So that change in concentration also multiples of half-life. Okay. So for a first order reaction, what is half-life? T half is equal to 0.693 by K. That is 0.693 by 2 into 10 to the power minus 2. That is the T half. Here, for this change, how many T half you have to take in? 2 T half. But 2 T half, what is 2 T half? 2 into 0.693 by 2 into 10 to the power minus 2. But 2 cancelled, 0.693 by 10 to the power minus 2. Okay, so 0.693 into 10 square, 69.3. So third option will be the correct option. So the change in concentration when you are getting, always you have to check in, is it a multiple of half-life? If the multiple of half-life, so directly you will be getting the answer. T half you have to note it, the 2 T half, so 2 times you have to take it, so you will be getting the answer 69.3. Okay, are you getting the idea now? Okay, are we following now? Shall we move to next question? The question number 19. The decomposition of a hydrocarbon follows the equation. One equation is given, rate constant equation. K is equal to 1 constant into E power. That means that this equation is similar to which equation? Arrhenius equation. What is Arrhenius equation? K is equal to A e power minus A by RT. A is Arrhenius constant, that is given as a fraction for 0.5 into 10 to the power 11. Then E power minus A by RT, that also given. So from this we can correlate minus A by RT is equal to minus 28,000 by T. K means Kelvin, temperature is in Kelvin scale. But T cancelled, minus also cancelled. So what is EA? EA is equal to R into 28,000. R in joule 8.314 into 28,000. So you multiply 8.314 into 28. Okay. 8314 into 28. When you are multiplying, you are getting the answer 232792. That is the multiple. This value is in joule. But the options are given in kilojoule. So kilojoule divided by 1000. So what is the correct option? First option will be the correct option. Joule value you are getting, because R we substituted in joule 8.314, it is joule Kelvin inverse mole inverse. So 28,000, 30 decimal, that is cancelled by 30, so the answer is 8,314 into 28. So you are getting 232792. That is in joule. Convert into kilojoule. Okay, are you getting the idea? Now the next question, question number 20. The role of catalyst is to change catalyst. The factors affecting rate of chemical reaction, one of the factor is catalyst. What is the role of catalyst? The main role of catalyst is it reduces activation energy of the reactant molecule. The extra amount of energy required by the reactant molecule to take part in chemical reaction, that is called activation energy. When you are adding a catalyst, catalyst will reduce the activation energy, so readily we are getting the product. So the correct option is, third one is the correct option. The role of catalyst is that will reduce activation energy of the reactant molecule. Okay, are you getting the idea now? These are the questions that is regarding the topic chemical kinetics. Now we are running through electrochemistry. Electrochemistry, there we are two concepts mainly we are studying: chemical energy into electrical energy and electrical energy into chemical energy. Electrochemical cell and electrolytic cell. The question, first question is, which cell measure standard electrode potential of copper electrode? You are familiar, electrochemical cell or reactivity series in which elements are arranged in the increasing order of their standard reduction potential value. How you are getting that reduction potential value? When a metal we are connecting with a SHE, standard hydrogen electrode. SHE at a constant potential, it gives a standard volt of 0 volt. So any half cell, when you are connecting with the SHE, you will be getting standard electrode potential. Here, which cell measured standard electrode potential of copper? So here the cells are copper, Cu and SHE. Any metal when you are connecting with SHE, that time only you are getting standard electrode potential. Clear? For copper and SHE. SHE will be get a 0 potential. So the potential of copper will be the standard electrode potential. Now here which one acts as anode, which one cathode? Which is more reactive, that anode, which is less reactive, that is cathode. Here copper and SHE. Hydrogen is above copper, they are in the reactivity series. So SHE acts as one anode and copper acts as a cathode. More reactive always anode, less reactive cathode. For SHE anode, here they are given some cell notation. In the cell notation, left side we are representing anode and the right side we are representing cathode. But here SHE anode, SHE means hydrogen is converted into H plus. Anode reaction, H2 changes into H plus in the presence of platinum electrode. For PtH2. Cathode reduction, Cu2 plus bar Cu. But this one we are writing left side and this one we are writing right side. So which is the correct option? Third one will be the correct option. Are you getting the idea now? Electrode potential. Is it clear? All electrode potential you are getting when a metal is connected with the SHE. When a metal is connected with SHE, That metal can act as anode or cathode depending upon the nature of the metal. Reactivity series hydrogen, above many metals are there, below also many metals are there. When SHE we are connecting with any metal above reactivity series, SHE act as cathode, metal act as anode. Okay. Any metal below reactivity series we are connecting with SHE act as anode, below metal act as cathode. Copper and hydrogen, reactivity series copper is below hydrogen, but copper act as cathode, anode SHE. Clear now? Are you getting the idea? Okay. Now, next question. An electrochemical cell can behave like an electrolytic cell. Electrochemical cell all having one E0 value, standard electrode potential value. Then there we are giving one external voltage. Okay, outside two half cell we are connecting. There we are giving an voltage. If the voltage is greater than that of E0 cell, external voltage is greater than stand EMF of the cell, then reverse process will take place. That electrochemical cell will be converted into electrolytic cell. Outside external voltage is increasing more than that of E0 cell, that thing it is converted into electrolytic cell. So which is the correct option? Third option. All cell having constant EMF E0 cell, that is electrochemical cell. That value decreasing and external increasing, that is converted into electrolytic cell. Okay, are we following now? Is it clear? Okay, moving to next question. Using the data given below, find out the strongest reducing agent. In our NCERT textbook also the first question is based on arrange them in the increasing order of the reducing agent. How we can arrange based on E0 value? Okay, if the reactivity series when you are starting potassium, calcium, magnesium like that, when you are starting both the direction we can write it. Suppose I am starting from potassium, highly reactive metal top, and moving down reactivity decreases. So their reducing power also decreases. Metals they are readily donating electron. They having reducing power. More reactive metal, more reducing power. But E0 value in more negative. More negative, more reducing. Moving down, negative intensity decreasing, reducing power decreases, oxidizing power increases. Here some E0 values are given. First one plus 1.33 per reducing power less because it is positive. It has oxidizing power. Second one 1.36. Third one 1.51. Fourth one only negative. Among these, which is more negative value? Fourth one. So that has a more reducing power. Which metal? Chromium. So the correct option is second option. More negative, more reducing. Negative intensity decreases, reducing power decreases, oxidizing power increases. Clear now? Two negatives are given. Suppose one E0 value is minus 1.02, another E0 value minus 0.822. Which one is better reducing agent? First one. More negative, more reducing. Are you getting the idea? Okay, now we can move to the next question. Are you following now? Yes or no? Okay, the conductance of a solution of an electrolyte is same as that of its conductivity. Conductance and conductivity same. The cell used can be said to have a cell constant. But in the sentence when you are reading, there you have to connect it. Conductivity, conductance, cell constant. What is the relation? Kappa is equal to G into L by A. This is cell constant L by A. Kappa and G are same. Same means L by A means kappa by G. Both are same, so the value becomes equal to 1. K and G are same, that is mentioned there in the question. Okay, now we can move to the next question. Okay, are you getting the idea now? Okay, next one. Copper sulfate solution is electrolyzed between two platinum electrodes. A current passed until 1.6 gram of oxygen is liberated at anode. Copper sulfate. We are electrolyzing copper sulfate solution. So cathode, what will deposit? copper. Anode, what is liberating oxygen, because copper sulfate is solution that contain Cu2 plus, H plus, SO4 minus and OH minus ion. Cu2 plus, H plus, which one has a more reduction potential? Cu2 plus. So Cu2 plus migrate towards cathode. SO4 minus, OH minus, which one has a more oxidation potential? OH minus. So anode oxygen will be liberating. Okay. According to Faraday's second law, okay, when two electrode substances are deposited, what is the weight ratio? Weight of copper deposited by weight of oxygen deposited is equal to equivalent weight of copper by equivalent weight of oxygen. That is the relation. All reaction we can apply this concept to Faraday's second law. When two substances are deposited or liberated, the ratio of their weight becomes equal to the ratio of their equivalent mass. Here, weight of copper, the current is passed until 1.6 gram of oxygen atom is liberated. For weight of copper, you have to calculate weight of copper by weight of oxygen. What is the weight of oxygen? 1.6 is equal to equivalent weight of copper, atomic weight divided by valency, by equivalent weight of oxygen, atomic weight by valency, 8. For 63.5 divided by 16. So you are getting the weight of copper is equal to 0.1 per 6.35 denominator. So 6.36, first option will be the correct option. Clear now? The ratio of their weight we can equate with the equivalent weight. What is the equivalent weight of oxygen? Equivalent weight is equal to atomic weight by valency. For oxygen the equivalent weight 8, 16 by 2. Okay. Then next question, question number 26. One Faraday of charge was passed through electrolytic cell placed in series containing solutions silver, nickel, chromium. Again, it is based on Faraday's second law. The amount of silver, nickel and chromium deposited will be amount of substance deposited. See, it is based on Faraday's first law, W is equal to Z into IT. Okay. Second law is same quantity of current we are passing through different electrolyte. Here 1 Faraday of current, 1 Faraday of current we are passing through Ag plus, Ni2 plus and Cr3 plus. You know how many electron is required for their deposition? What is the equation? Ag plus 1 electron gives Ag. What is the meaning of this one? 1 electron means 1 Faraday will produce 1 mole Ag. 1 mole Ag means 108 gram. Then Ni2 plus how many electron is required for getting 1 mole of nickel? 2 electrons. So 2 Faraday will produce 1 mole. So in the case of chromium, 3 electron will get chromium 1 mole. For getting 1 mole, 3 Faraday of current is required. But in the question, we are passing only how many Faraday? 1 Faraday only we are passing. 1 Faraday when you are passing, the amount of substance deposited. For silver will be depositing 108 by 1. Then nickel only 1 Faraday we are passing. 2 Faraday need 1 mole. For 1 Faraday, what is the atomic weight of nickel? 59 by 2. Chromium 52 by 3. Are you getting the idea now? How many electron is required? Same Faraday we have to pass it for getting 1 mole. 1 mole means what is its atomic mass? That much gram you are getting. Here all electrolyte we are passing only 1 Faraday of current. For silver 1 mole will be deposited because the valence of silver is 1. Nickel, the valence of nickel is 2 plus, it is mentioned there in the question. For getting 1 mole of nickel, we have to pass how many Faraday? 2 Faraday. But here we are passing only 1 Faraday. So how many will be depositing? 59 by 2, 29.5. Chromium 52 by 3, 17.5. So first option will be the correct option. Are you getting the idea now? Okay. Now we can move to the next question. The standard electrode potential for the reaction, 2 reactions are given. Ag++ 1 electron gives Ag reduction, Sn2++ 2 electron gives Sn. At 25 degrees Celsius are 0.8 volt and -0.14 volt respectively. The EMF of the cell. Okay, EMF of the cell means we have to use which equation? Nernst equation. EMF of the cell, E cell is equal to E0 cell minus 0.0591 by N log concentration of product by concentration of reactant. If the number of moles is there, that number of moles you have to give it is power of concentration. Here you have to note it E0 cell. E0 cell is E0 cathode minus E0 of anode. Which one acts as cathode and anode here? E0 values, silver plus 0.8 volt and tin minus 0.14 volt. More negative, more reducing power, more reactive. But negative acts as anode, positive acts as cathode. So what is the value you are getting? E0 cathode 0.80 minus -0.14. So the answer is 0.94 volt. That is the E0 cell. Now product concentration and reactant concentration, just to check it. Sn2 plus 1 molar, Ag plus 1 molar. So here when you are substituting log value, there you are getting log 1. But is log 1 0? So E cell becomes equal to 1, E0 cell 0.94 volt. So fourth option will be the correct option. Both the concentrations are same, 1 molar, 1 molar. Okay. 1 molar square is pannialum, square or cube when you are using, the value will be 1 only. Log 1 is 0. So E cell becomes equal to E0 cell. Okay. Next question. A chemist want to produce chlorine from molten NaCl. How many grams could be produced if we use a steady current of 2 ampere for 2.5 minutes? Again Faraday's first law, amount of substance deposited, W. How to calculate W? W is equal to Z into IT. What is Z? Electrochemical equivalent. How to get Z? Equivalent weight by Faraday into I into T. Here chlorine, what is the equivalent weight of chlorine? Atomic weight by valency. What is the atomic weight of chlorine? 35.5. What is the valency? 1. 35.5 is the equivalent weight of chlorine by Faraday 96,500 coulomb into ampere. How many ampere current? 2 ampere current. Time, when you are substituting 96,500 coulomb, time must be in second. 2.5 minutes, 2.5 into 60. So you are getting the weight. When you are calculating this one, you are getting the answer 0.11 gram. So third option will be the correct option. W is equal to ZIT, Faraday's first law. Weight of substance deposited or liberated directly proportional to quantity of current passed through the electrolyte. W proportional to Q. W is equal to Z into Q. Q is I into T. Z. How to get Z? Equivalent weight by Faraday. Equivalent weight of a substance or element, atomic weight by valency. Here chlorine, atomic mass 35.5. Cl2, we are not taking Cl2 71. Equivalent weight is atomic weight by valency. Okay. Shall we move to next one? 29. E0 chromium, E0 of iron are given. Which is more negative? Minus 0.72. For chromium acts as anode, iron acts as cathode. The potential of the cell, again Nernst equation, E cell is equal to E naught cell minus 0.0591 by N log product by reactant. Number of moles you have to give it as power of concentration. Here the valency metal is different, Cr3 plus Fe2 plus. But Cr giving Cr3 plus 3 electron, Fe2 plus 2 electron gives Fe. Okay. So what is the overall reaction? Cr equation you have to multiply with 2 and Fe equation you have to multiply with 3. Then only you are getting the overall reaction. Cr 2 Cr plus 3 Fe2 plus gives 2 Cr3 plus 3 Fe. That is the cell reaction. How to get E0 cell? E0 cathode minus E0 of anode. What is cathode here? 0.42 minus 0.72. E cathode minus E anode. So you are getting the value 0.30 volt. 0.30. Now we can calculate E cell is equal to EMF of the cell is equal to 0.30 minus 0.0591 by what is the N value? 6. How many electron cancelled? That is N value. Then log product Cr3 plus. What is the concentration of Cr3 plus? 0.1 the whole square by 0.01 the whole cube. That is EMF of the cell. Then calculate, that is equal to 0.30 minus 0.0591 by 6 log 0.1 10 to the power minus 1, 0.01 10 to the power minus 2, but 10 to the power minus 1 the whole square, 10 to the power minus 2 by 10 to the power minus 6. That is 0.30 minus 0.00985 into log 10 to the power 4. What is log 10 to the power 4? 4. When you are multiplying 985 into 4 and subtracting from 0.30, you are getting the answer 0.2606 volt. Nernst equation. Okay. If the valency of the metal is different, first you write the cell reaction, then only you have to calculate Nernst equation formula. Formula must be clear, log product by reactant minus. For easy calculation, sometimes the log fraction reverse way also we can write in reactant by product. That time plus sign you have to use it, which is easy calculation. That way we have to frame it. When you are using minus sign, log product by reactant. When you are using plus sign, log reactant by product. Which way easy calculation, that way you have to frame it. That all we can frame through practice. More number of questions you have to practice, that time it will become easy. Okay. Then, shall we move to the next question? Question number 30. What is the sign of delta G0 and the value of K for an electrochemical cell for which E0 cell is equal to 0.80 volt? Here it is relating delta G0, equilibrium constant and E0 cell. You know E0 cell is positive, then only the cell can be warm. Then what about the delta G0? For all spontaneous reaction, delta G must be negative. Delta G0 is equal to minus 2.303 RT log K. That is the relation. Equilibrium constant, free energy change. But delta G0 must be negative. Negative value is there. But log K, this log K value must be positive. Log K, if it is negative less than 1, the result become positive. But delta G0 positive means non-spontaneous. But all electrochemical cells are spontaneous reaction. But K must be greater than 1. And delta G0 must be negative. That is a condition for electrochemical cell. So which option will be the correct option? First option will be the correct option. Delta G must be negative and K is positive, greater than 1. Less than 1 means a negative value will be coming. But negative into negative, delta G become positive. Positive means a non-spontaneous. All electrochemical cell reactions are spontaneous reaction. Okay, are you getting the idea now? Now we practice some questions based on the topic hydrocarbon, chemical kinetics and electrochemistry. Like this, you have to approach a maximum number of daily, you have to practice a maximum number of questions, then the topic become easy. Okay, by this I am concluding this section. I think you get some idea regarding this topic, and based on this one you can practice more questions. Okay, practice well. Okay, now I am winding up this session. Okay, thank you for your cooperation.